motivation of this paper to begin with, but there was maybe two parts of it. One was just a broad question about the application of machine learning into a real world setting and what that looks like, but then a much narrower sense of the application of fairness notions into an applied setting, and this question of how much fairness can be achieved through modeling or through computation, and what are the limits on that. I work really at the intersection of practice and norms and data. And when I'm working with an organization who wants to use data to do a better job, they often don't know very much about machine learning or even about fairness. And so there's often the case is there has to be some sort of guidance provided to them about what you can do with the data and what needs to be figured out on their end. So oftentimes this means having a whole series of conversations with stakeholders or clients or constituents, staff or leadership about what they want to achieve in terms of fairness. And so it's some of those ideas of what I want to talk about today. I think it's important to consider fairness in applied settings. Oftentimes, some considerations of what fairness is become really difficult to think through about what that would mean in an applied setting. And I think that gets especially true when we talk about a justice setting where there really is a high expectation of equity and equality and fairness and justice, and about kind of what the consequences of getting it right and getting it wrong really mean. There is some hesitancy to really trust data and models across justice settings in the United States, but at the same time, risk assessments and data-driven structured decision supports and machine learning are really standard practice all across the United States and large parts of the world. So even though people are sometimes a little bit nervous about putting them in place, basically everywhere uses some kind of risk assessment across justice settings. One of the things that's interesting about applying machine learning into a justice setting is that the setting itself is pretty sticky. They don't change practice or policy or procedure very often. So finding a way to improve practice or to better inform practice usually takes quite a bit of work around the implementation of models into justice justice agencies, of saying not just here's a model, but how is this model going to fit into existing practice, and existing practice that is just not real likely to change very much very fast. There have been, probably everybody knows here, a real proliferation of codes of ethics over the past couple of years. And there's also been a rapid increase in good scholarship on fairness and machine learning. And that, a lot of that, not all of it, but a lot of it came from the ProPublica analysis of Compass and the release of that data for other scholars to use. In the analysis of the ProPublica analysis of the Compass revealed a couple of things. One was that not very many people had ever seen really the workings of justice setting risk assessments. And Compass is used lots of places, but there's lots of other risk assessments used in other places. And it's not real common for people to get access to those to see what's going on. I think the other thing that came out of it in an important way was that the differences in opinion between ProPublica and Northpoint, the maker of the tool, was that there could be legitimate differences while still having good faith. That is, both ProPublica and Compass, the Compass people, could have different notions of fairness in mind at the same time, and their disagreements were not about what was calculated wrong, or what had been measured wrong, but instead it was about what's the appropriate notion of fairness to apply to a justice risk assessment. And so that fundamental sort of disagreement was what was kind of sort of compelling about the story of was North Point choosing the wrong method, or was ProPublica choosing the wrong notion, or really is there some other way that has to be decided about which thing to be focusing on in terms of measuring fairness? And really, there are so many guidelines and codes. Like here's just one example of a paper that identified 22, but there's way more than this now. It's easy just to go online and find codes of ethics for machine learning, and a lot of them talk about fairness. A lot of them say machine learning should be fair, it should be equitable. They often don't provide much practicable advice of how would you actually achieve this, or what is the metric by which this would be measured. And there's a risk to this of for fairness to become a platitude, to be an empty statement, like it's true, machine learning should be fair, but without saying anything more than that, it really has no meaning because it's been said so many times before. And you get to this point of someone saying machine learning should be fair, and nobody's going to disagree that machine learning should be fair, but the question is, what should be fair, and whom should it be fair for, and how should you be measuring fairness are the bigger questions, not just whether machine learning ought to be fair. Along with the different codes, there's also been an expansion of the notions that might apply. And here's another example of Verma and Rubin found 20 measures. There's lots of other papers now that talk about different notions of fairness in different ways, but the big point here is that this is really too many to be used on any effort. So if you are creating a machine learning model here, which of these notions are you supposed to be applying? There's no way that all of them would make sense. So somehow you're going to have to pick which things apply. And that could change quite a bit by domain or setting, but still there has to be some kind of way to choose which kind of fairness is going to be applied in what kind of setting. At the heart of a lot of the discussions of machine learning fairness are impossibilities or trade-offs. And there's two here that I think are core. One is that an increase in fairness might come at the cost of decreased accuracy. It is, if you're going to take a model and say, I want to make it more fair than it was before, that's generally going to come at a cost of decreased accuracy. So someone who wants their model to be more fair, they might have to come into it saying that they're willing for it to be less accurate because it's going to be worth it for it to be more fair. And the second trade-off here is that between equal proportions of each racial group getting a high score on one hand, and equal rates of positives by score across racial groups cannot be both achieved. So this is sometimes called sufficiency or predictive rate parity versus separation or equalized odds. And there are also other terms sometimes used in the literature to describe it. But there is just a fundamental piece here of what distribution of scores you expect to see by racial group. And if you want those to be fair, that you're not going to see the same rate of positive by score, the same rate of positive score across groups. The big issue in a justice setting is that no one really is going to be happy with these trade-offs, from political leadership to agency and bureaucratic leadership, to workers and frontline workers, to constituencies, to impacted communities. Nobody is really going to say that they are comfortable with the idea that they have to make these trade-offs. One of the reasons for that is because false positives and false negatives are so consequential that people really want to avoid both things, and it becomes really difficult to avoid both. but false positives can have this like massive impact on a person, their family, their community, the long and the short term. The literature on the impacts of justice involvement is rich literature, and it's overwhelmingly negative impacts. But at the same time, false negatives can also be devastating for victims, for communities, especially as preventable crimes and even violent crimes that just didn't get prevented. You also have false negatives, people who really needed supports who don't get support. So there's no easy way here to say that false positives are more important than false negatives objectively, but in any given jurisdiction, they might weigh these things in different ways. And certainly different stakeholders are going to say some things are more important than other stakeholders. So a prosecuting attorney is going to see this one way, while a community advocate might see it another way. It also needs to be really clear and overlaid with the fact that in the United States, especially Black and African American people are overrepresented across every justice setting decision, including things like stops, searches, arrests, referrals, bail decisions, arraignments, adjudications, sentencing, denials of parole, probation terms, and on and on. Like across every single part, African American people get worse outcomes and are overrepresented. So in these consequences where the false negatives and the false positives are so damaging, and the sort of overlay of structural racism and inequality, it becomes really difficult to make this work in an applied setting. Another way of thinking about some of the same things is the fact that nearly every feature that is useful for predicting the outcome, so like rearrest, readjudication, they are also statistically related to being Black and African American. And so you get this kind of triangle relationship where criminogenic factors, factors that predict justice involvement, are correlated both with racial groups and with justice system involvement. And then you get this justice system involvement now being related to racial group. And you can say like, oh, let's not use these factors because they are related to race, but that's essentially going to leave you with no factors at all. So part of the solution around this is a map of Minnesota, and Minneapolis is highlighted there. Is that the some people in the community care a lot more about procedural justice than they care about the exact workings of the machine learning model itself. They care about how was the model developed, who did you talk to, and who was involved in the process, who got to comment on the model and the definitions and the features. And so when Minneapolis went into this saying we want to create a new machine learning model for risk assessment, they said before we even get the data, let's do listening sessions. Let's talk to people in impacted communities to see what they think is important and what they see about the whole process. And impacted community members themselves can't speak to the machine learning model generally. It's just not in their knowledge base, but they can speak very much into like what does the process look like and what's important. So in some cases, fairness and the impossibility trade-offs that I mentioned before can really be not a dead end because people care about other aspects of fairness, not just the machine learning fairness itself. The other way potentially around it is to change the nature of the intervention, not necessarily change the model, but change like what does the model produce. So if we have a model and we use that model to determine sentencing or out-of-home placements or which youth go to detention centers, then it's going to be really hard to find a path through the fairness in the machine learning model. But on the other hand, if the intervention were something else and it were how to apply community supports or how to allocate funds to different people in different neighborhoods and things that are mostly positive, then some of the tension that comes with the trade-off really isn't as difficult to get through. So I mean, a false positive when you're applying prison is pretty bad, but a false positive when you're providing food and housing credits maybe isn't as bad. So that's what I wanted to go through, and I appreciate any questions people have. And I also just say, if people want to think about these two questions of, in a justice setting where different errors and play different real world impacts, how would you rank these things? And this isn't really a purely theoretical question. This is a real question that comes up of, how do you want your model to achieve more false positives, false negatives, but also how those break down by racial group. And then the other question is, like, how much accuracy would you be willing to give up in order to create some kind of parity in accuracy across racial groups? So there's two things to maybe think about that aren't really, there's no really right or wrong answer here, but it's a way of thinking about how you apply this kind of model into a real world situation.
Thank you very much, Jesse. So I stop the recording now.